All right, welcome to our next video in our series Programming in Java. This is my reference semantics video. This video is going to assume that you've been introduced to arrays, that you know how to declare variables, that you know how to define a method and pass a parameter to that method. Those are all the prerequisite skills you need for this video. What are we going to be talking about? Well, it turns out in Java, our types of data are divided into two categories, value and reference semantics, or what are sometimes called value types and reference types. We're going to compare those. We're going to see how they work differently. We're going to talk about when's the right time to use each one in your code. And the way that we're going to reveal those differences is using methods and variables. So what are we going to do here? Let's start out with what we know, what's comfortable and familiar. I'm going to say int a equals 5. And int b equals a. And this is a technique that's probably not terribly common so far in your study of programming. But the idea is I wanted to assign a value to a, and then I wanted to ask b to get the same value. And the question we might not know right here is, are a and b linked? Like when I change a, does it make b look the same? Can we see changes in B appear in A? And so what I'm going to do is I'm going to go ahead and print out both variables here. We're going to go ahead and print out maybe. There we go. I'm going to print out A and B. Concatenate that together. So when I go to run this code here, whoops, did that go to the wrong? It sure did. Run this code here. We should see that they're both 5 and 5. All right. Let's go to change them. I'm going to say, A, you add 1, and B, why don't you double yourself? And then after we've made these changes, let's go ahead and print out our variables again. Do they hold the same number? Do they hold different numbers? We go to run our code, and behold, they are different numbers. And the reason for this is that primitives are value type, or they use value semantics. And what that means is when I refer to one of these variables, I'm going to get a copy of whatever is stored there. So value type means that we are sent copies of the value, and we're going to see that changes made. Well, we'll talk about that in methods in a second. Let's not get ahead of ourselves. So A held a 5, B held a 5. I increased A by 1. That created A being 6. I said B, whatever you were, multiply yourself by 2. That gave me 10. So we see that they are independent. Now similarly, if I make a method, public static void -3, let's call it -3, and it takes in an int, num, I'll call it int num. And I'm going to go ahead and say, num minus equals 3. And that's the job of this thing, is to change this particular int. And then, maybe, I guess I will print out right here what that value is. So we'll print out num. So what I'm going to do now is I'm going to take A, which when last we saw it, it was 6. And I'm going to pass it down to this method -3. -3, let's go ahead and pass A down. And when we run this, we should see that 6 turns into a 3. And the reason is we printed the value num from within the method. But when I come back up to the main method, where A was declared, and I check after my -3 method was run and I look for a result, we're going to see that the answer is 6. Now this is what we talked about when we first defined variables and parameters, when all we knew how to pass down to those methods was primitive values. The mantra I gave was, you're going to send a copy. If you ship something down there, don't assume that change is permanent, assume that the change is temporary. And that's because primitives are value type, and value type send copies as parameters. And for that reason, we see changes made by methods are temporary. They are temporary. This is the world that we have known up until the arrays chapter. And arrays are one of the first most significant non-primitive types that we deal with. Strings are probably the first significant non-primitive type, but because they're so important, used so frequently, they have a lot of ways that they bend and break the rules. And so they're not often a good example to hold up for a non-primitive type because they do such weird things. Arrays, on the other hand, are very consistent in what they do, and we're going to be able to see how working with them is going to work a little bit differently. So let's go ahead and make a couple of arrays. I'm going to say array pi. Oops, I should use the right syntax though. An array of ints called pi is going to be equal to 3, 1, 4. So notice I'm using the array declaration shortcut here, so I don't have to spend 3 statements assigning a 3 to index 0 and a 1 to index 1 and a 4 to index 2. And then I'm going to make another array of ints, and we'll go ahead and call this E. Boy, I hope I remember my digits of E. Okay, 2, 7, 1. I think that's right. So I've got a couple of arrays right here. Oh, I've already goofed up. Let's. I'm going to call this. Let's see here, pi, and then let's call this. Boy, pizza. I'm just going to call this. Yeah, we'll go with pizza for right now. And I'm going to connect pizza and pi. I'm going to say that pi is assigned to pizza, much in the same way I said that A was assigned to B. And so I go to print these out, and here's a little reminder in case we forgot. If I go to print out pi, and I go to print out pizza, if I try to print out the arrays, I end up with this nonsense. And you might think to yourself, oh, my code broke. What's this nonsense? Remember, when you're trying to print out an array, it's going to give you the location in memory. Remember our analogy of the great memory waffle, a vast plane of squares that hold values and pointers to other squares. This is basically how Java sees your array. It doesn't think you want the elements inside the array. It thinks you want the identifier that gets you to those elements. So how do we make sure that we're actually looking at the elements? Well, we could write a method whose job it is to traverse the array and print out all the elements, but I think it's easier to use the good old-fashioned method arrays.toString. Arrays is a cool class that contains a bunch of static methods that we can use, one of which is really important is toString, and it allows us to see everything inside of an array in a very nice clean format. You'll notice that Eclipse manually imported the arrays class in for me. Thank you, Eclipse. That was very kind of you. And we can see that pi holds 314 and pizza holds 314. All right, so we're good so far. This is the same thing that happened before when we printed out A and B, they were the same value. Now the question is, if I change pi and if I change pizza, is just one affected or are they both affected? Because before, when I changed A, the variable A that's an int, only A was affected. When I changed B, only B was affected. So even though I had assigned A to B, B had only received a copy, and that made all of its changes independent. It meant that when we passed one of these variables down to a method, the changes were temporary. Let's watch what happens now. I'm going to say pi of 0, that's not a 0, pi of 0 plus plus. That means go get the first element of pi and add 1 to it. So that should turn 314 into 414. And I'm only going to give that command, and I'm just going to ask to print out those two array values again one more time and watch what happens. Both arrays changed. And that's really the big revelation of this video, is if you are making a reference to one of these arrays, whether it's assigning that array to another array, or as you're going to see in a moment, if you pass an array as a parameter down to a method, it will not send a copy. It instead will send a reference to the array. And another way to describe that is we would say it's a pointer, meaning that we don't send the array itself because an array is too big and complex in memory to make a copy of, and Java would rather just tell you where to find the array when you need it. The effect that that has is that changes made to one are made to both. And the other effect is when it's passed as a parameter to a method, we'll see that the changes made there are permanent. And the reason is we're not dealing with copies. We are dealing with a reference to the original. And when the original gets changed, all references to it, all pointers to it, also change. So pi and pizza both point to the same array in memory. I'm about to write a method that's going to mess with this array. Where it messes with the array, the name of its parameter also points to the same place in memory. This is different than A and B, who were copies and had unique places in memory, which is why a change to one was not seen in the other. So let's make our method. I'm going to say public static void. How about swap first two elements. That's a good one. Swap first two elements. And we're going to take an array of ints called R, like a good pirate. Yar. I've seen a lot of students name their arrays yar or yar. Be careful getting carried away with that. Remember, identifiers should convey functionality or intention. So I'm going to say, all right, the first element is going to be equal to R of 0. And then I'm going to say R of 0, you get to have, what was it, R of 1. And then I'm going to say R of 1, you get to have where there was first element. And some of you might be watching this and thinking to yourself, geez, isn't that an extra line of code? Can't you just say R0 equals R1 and then R1 equals R0? What did you do all this fanciness for? And the reason I had to store the first element is after this second line, R1 is going to override R0. R0 will cease to exist. And if I had not stored it in first element, it would not still be there for me to move the R0 element into R1. Hopefully that made some sense. So let's go ahead and look at another example here. We saw that changing a reference to one changed the other. What happens if instead we declare an array, print out its value, and then what if I want to go ahead and send that array down to swap first two elements. We'll send down pi, and then we will print it out again. I think that's what I want to do. So I've changed out the addition of the add to the first element, and instead we just want to see what effect passing down has had on that array. And sure enough, beforehand, it was 314 for both pi and pizza. When I sent down pi as a parameter, and it got messed with here, the 1 and the 3 got switched. When we resolved that method and came back to our main method, we saw that that change was permanent. So we would say that reference types send pointers or references as parameters. It means you get the original copy. Changes made by methods are permanent. The reason we're covering this now is because when you pass primitive values and non-primitives as parameters to your methods, you're going to see them behave differently. And the syntax looks the same. And so you've got this opportunity to incorporate a logic error, where if you thought a change was temporary when it was permanent, or permanent when it was temporary, you can get yourself into some trouble. So let in the back of your head while you're developing your code, if you use an array as a parameter and you make any changes to that array in the method, just know that those changes will persist even after that method is run. That, folks, is the difference between value semantics and reference semantics. Thank you for watching.